Hey, what's up, people? This is a Goldsource STU-1000 step up and down transformer. It's not a particularly exciting device. It'll take an input voltage that you select in the rear, and it'll output a fixed 110 volts on this left outlet and 220 volts on the right outlet. And you may have seen or even used one yourself before, but if you're not familiar with them, they're basically useful for powering devices from like different countries, which may require like different mains voltages, outlet types, and it'll let you use them on your local outlets and voltages. So we have a breaker on the front, which doubles as a power switch and a USB outlet for charging phones and other similar devices. When we flip it to the rear, we have an input selection plug, which allows us to select between 110 volts, 200, 220, and 240. Now, because I have 120 volts at my outlets, I would select 110 down at the bottom. And there's also a fuse holder, which I actually don't know what fuse rating is on this because it's not labeled. So let's take it out and check. That's a 10 amp fuse, and it appears to be a fast blow. The plug on the unit is this basically a North American like standard plug. So if you're going to use it on like another voltage, you're going to need an adapter. So it has these, which you can just plug into there. And now you have like this, I think this is what, like the European style plug? I'm not entirely sure. I don't know my international plugs, but you have that option. And there's also, I don't know if this actually came with it or not. This unit was actually given to me like many, many years ago. And I haven't really had like any specific need or use for it, but I've kept it around in case I ever needed to power up something that required a higher voltage from our mains voltages. And if we plug it in and turn it on, and let's go ahead and pull up the multimeter, we can see that the voltages, so yeah, that's almost 120 volts right there. So the input and this outlet are about like 1-to-1, and this one here should be double, so it's going to be almost 240 volts. Yep. There it is. So it works. Like I said, there's really nothing remarkable about it. It does what it says, and it does appear to work correctly. So why am I even like bringing this up? Well, it's not what's on the outside that I want to show you. It's what's on the inside, because I did open this up a while ago, and what I saw inside had me a little bit concerned. And let's take a look at it from above. Here we go. I've already removed the screws from the cover. And here is that top strap. I'm just going to remove that. On first glance, you can't really tell very much, but let's go ahead and zoom in. And if we uncover some of these solder joints, I don't know how well this is going to come through on camera, but we've got some pretty abysmal looking solder joints. And this stuff is not heat shrink, or it doesn't appear to be heat shrink. It's like a hard, like a plastic, almost like straw material. Look at that. That looks pretty bad. And it looks like a lot of these solder joints are just being held on by like hopes and dreams. So, like I said, this device works. And as you saw, it does work. It's just not very well constructed. So I kind of want to improve it some. I mean, look at that. That's just, it looks like it's just barely tacked on onto that terminal. So, yeah. Oh, and check this out. Check this out. Look at this ground. Basically, they just pinched it up against the case. If we loosen up the screw on the bottom, I believe that should probably just be able to get pulled out. Oh, wow. Is there actually a ring terminal on that? Oh, there might actually be a ring terminal on that. It didn't appear to have one. Oh, I guess it does. Yeah, so it does. It looked kind of wonky there. Okay, so that's not as bad as I thought. I thought they had just like maybe soldered up the end of the wire, just tucked it in underneath the transformer and bolted it down. These terminals going to this USB board. This one looks like it's about to break off any second. Look how much that wiggles. It's like super weak looking. That looks pretty ugly. I don't know about the bottom, but the top definitely looks ugly. This is that little neon indicator in the front. I mean, just got two. Look at all that extra solder that's just sort of like spattered onto the wire. And lastly, check out those the 220 volt connector down at the bottom. Yeah, that all looks it's just ridiculous how they solder this together. So it isn't really like meant to be a repair. I just want to improve the thing to make it maybe a little more like dependable, reliable, so that stuff doesn't just kind of like come off at some point. And so what I intend to do is remove all these solder joints, maybe trim the wire, make it look nicer, and actually put some decent heat shrink on all of these wires so that everything's like nicely protected. There's no risk of any of these solder joints like, just breaking from vibration over time. And one other thing about this is that I thought that maybe it was sort of like a isolation transformer, like where you had an input and then it had the outputs in the front. So then you basically just select which portion of the coil you're inputting the voltage into, and then it'll provide like a steady output. It appears that that's not the case, and it seems that the output is still somehow connected to the input, because if we were to check resistance between the input and the outlets, we still do get continuity, and I can actually show you that. So if I flip the breaker on and we touch between, like this would be the neutral, and so if I touch it to any of the outlets, you can see that right there we have just about 1.3 ohms. If we touch it to what would be the live, we have basically nothing there. It's like a straight through. So same with the 220 volt outlet. This one's almost 6.5 ohms right there. And then on the other side we have about, let's see, pretty much nothing. So I'm not entirely sure how this transformer is wired, but like I said, it would have been nice if it would have been more of like an isolation transformer type of thing. I guess maybe I can come up with a diagram after I sort of analyze this and see how it's all wired and see where, like certain coils are. So the first thing I'm going to do is maybe take some pictures of where everything is wired, so that way I can just completely take everything apart. And then when I go to solder everything back together and put the heat shrink and all that stuff on, I know exactly where it goes. But that way, at least I can like pull the transformer out. I can pull this breaker out. I'll probably maybe like put some ferrules or something on some of these connectors. And so we'll go from there and see how it turns out in the end. All right, so I've got the entire thing taken apart, and we can now take a look at some of the carnage of everything that was in here. For starters, I didn't realize this when I took it apart, but there's like a blob of solder on the breaker that must have fallen from when they were soldering the wires to the neon, because this would have been sitting like right above it like that. So that's just a little solder ball that got stuck to it. I mean, that's not a big deal. But some of the other stuff that's kind of terrible, this is the neutral wire coming from the mains cable. And this was connected to one of the terminals on the 220 volt outlet. And on the 220 volt outlet, they were all ring terminals that are screwed into the back of the plug or the outlet. And I was going to remove these, but it looks like I might break the tabs if I try a little too hard. So I decided to just leave them in there. I did take a screwdriver and remove all these ring terminals. So I will solder directly back to those because it looks like they're meant to fit in there. So I don't have anything that is identical to those that I can use. So those will have to stay. But the wire itself, look how much was stripped on that. So there's a lot of exposed wire behind it. And as we can see, there's like a lot of like spattered solder. So pretty terrible all around. And like I said, this was like super easy to just pull off the terminal. It didn't take very much effort at all. On the neon, the soldering was just barely existent. Like it was just stuck to like a very tiny corner of it. So these were like super easy to remove as well. So I'm going to try to do a better job soldering the new wires to that. This is the USB power supply. Nothing crazy going on in here. It has a full bridge rectifier in this section, some capacitors. And so it's all, I mean, I can't really say that there's anything like specifically wrong with this or anything. It looks a little dirty, like they didn't really clean this off very well, like the flux residue and all that. So it looks kind of grimy, but other than that, I don't think there's anything like inherently wrong with it. These wires that they use to go to the LEDs are like
really thick gauge for the function that they are providing. So maybe I'll replace those with some thinner gauge cable or a wire and everything. I mean, they use like hot glue for everything in this thing. There's like a bunch of globs of hot glue that I had to remove from the outlets and from like other stuff. So I don't think I'm going to put any of that back on. On the LEDs, it makes a little more sense just because there's nothing else that will hold them in place. So I'll see if I can do something about that. For the time being, I can just remove these out of, there you go, their little hot glue prison. On the back of the voltage selector little plug thing, I'm going to have to leave a wire like this going to the one side. And on the other side, I'm going to clean all these up and resolder the terminals from the transformer. And on that, one of the wires is like completely split all the way up to about right there. And so all that was kind of exposed. I mean, it was covered up by like one of these little tubing pieces. But as you can see, that'd be completely exposed if you peeled back the outer jacket like that. So I'm going to have to trim that and to try to make sure that it's a little more secure once I put the heat shrink on it. So yeah, very, very crappy soldering job that was done on this thing. The screws that held the transformer to the rest of the case, I'm going to replace those. I'm going to replace them with some nuts and bolts and washers. And I'm also going to put ring terminals on all of the grounding connections. That way I can just bolt everything down to one of the bolts that's going to hold the transformer in place. And instead of like hooking this up with like being all daisy chained to the outlets and then going back to the case, that way they're going to have like a central point that all of them connect to. I think it'll be a little bit safer that way. So I'm going to have to drill out the holes on the transformer little tab mounts a little bit, not very much, as well as maybe straighten them out a little bit. They're all crooked, almost like if maybe this thing was dropped or something and it bent the tabs. I had already bent one of these a little bit. I don't remember which one it was. Maybe it was this one. But yeah, all of them were all just kind of bent out of place there. And I did draw a little diagram of how everything connects inside of this unit. So we've got the transformer, we've got the two USB, the brown wires that come out of it. Those are pretty self-explanatory. The neutral comes in, and that just connects directly to what I labeled pin number 5 on the transformer, as well as one of the terminals of the 110 volt outlet, and one of the terminals of the 100 or the 220 volt outlet. And those also go to the little neon bulb. So neutral goes to the bulb. The live comes in, it goes through the breaker, it goes to the fuse, and then to one side of the voltage selector block. And from there, we can see that the 110 volt connection goes directly into the transformer, as well as the 200, the 220, and the 240. And we have two wires that are tapped off. One's black and one's yellow, and those go directly to the outlets. So yellow goes to one side of the 220 volt outlet, and the black goes to the 110 volt outlet. And so basically what this is I'm not an expert on transformers or anything, but I believe it's what's called an auto transformer. And so I was able to determine that it's basically connected like this. There are no like separate coils or anything. It's in the simplest terms, it's one entire coil that has multiple taps. So we have the neutral that would connect to one side. And then when we select the 110 volt outlet, we can see that the transformer is connected in basically in parallel with the power coming in. And so we're tapping the voltage for the outlet between the neutral and that particular pin right there. So this would be providing 110 volt at the lower voltage outlet. And then since the 220 volt outlet is connected to the 220 volt side, the transformer itself acts as a step up. And so we get a higher voltage out on that particular tap. So that's how we're able to get the 2 voltages at the output. And then if we were to select the 200 volt option, then we can see that the 110 volt is getting generated like down here, but the 220 is coming from the other tap that's a little bit higher up. So we still get the same voltage outputs. And if we have 220, obviously, we have 220 coming out of here, but then we have the 110 coming out from the lower tapped winding. So I hope that kind of makes sense. And this is why we can't have an entirely isolated output from the input, because it's all part of the same winding on the transformer. So everything's pretty straightforward, so it's not going to be a big deal to put back together. Oh, and one quick thing I forgot to mention is that the USB is the only one that has its own separate coil, so that's completely isolated from the input. I think the only connection in this entire thing that had like a decent amount of solder and was like really properly bonded was this grounding point on the 110 volt outlet. You can see that it's got a decent amount of solder on that terminal. Everything else was pretty crappy, so I think we can do a much better job than was originally done on this thing. So first thing I'm going to do, that's going to be very simple, is to just enlarge the holes on the mounting tabs. And there we go. It's a little snug on the fit, but that should be totally fine. And I'm going to clean up all of these terminals that I'm going to be resoldering to. Trying to get all these pieces of wire that I left on there. See how chunky that one is. Actually, for the neon, I'm going to do something a little bit different. I'm going to clean off all of the solder that's still remaining on them, on the terminals. And instead of soldering wires to the back of this, I'm actually going to put like a little spade female terminals that I can just slide onto it. And then that way, if I need to remove it for whatever reason, like if it stops working, I can at least pull it off without having to desolder anything. The wires can remain inside of the rest of the unit. So to clean these up, I'm just going to use some solder wick. I heated up this white wire to remove it from the back of the fuse holder. And you can see that the only place where it was actually making contact is in that very tiny corner right there of that terminal. This is, I kind of just like smeared it on there, but it was just basically stuck onto that little tiny portion of the fuse holder. And everything's starting to come together quite nicely. You can see that I have heat shrunk all of the terminals that I have resoldered onto the terminals of the outlets. And I can kind of see why they would have burnt up those cables or the wires like so much. It's because it was very difficult to get solder to stick to the terminals. But since I actually tinned them first, it was much easier to get the solder to flow once I was actually going to attach the wire to each terminal. And so what I think happened is they were just heating the crap out of each wire. And maybe they were just holding it with pliers or something so they wouldn't burn their fingers. So in doing so and heating the wire up so much and having to hold it with a plier, it would like damage the jacket. And I think that's why on the wire over here on the transformer, that's why the jacket was split open and like damaged. So I've tried to keep everything neat by zip tying all the wires together. I did not daisy chain the wire coming from the neutral from one outlet to the other. Instead, I've got two separate wires that are going to be going towards the rear of the unit. I've got two separate grounds, and I have crimped some ring terminals onto both of those. Those are going to attach to one of the new nuts and bolts, and I still have to like heat shrink or put heat shrink on them like this. This is just to support the end mostly. Not that I really think this needs it, but I do want to support the wire to the body of the ring terminals a bit. And this is what I was talking about on the neon indicator. I was going to put two spade plugs like this. Now, unfortunately, the actual terminals are much thinner than what would normally be used to mate with these connectors. So they're pretty kind of like loosey-goosey in there. So what I'm going to do for that is I'm just going to give them a slight little squeeze just to decrease the distance between this side and the little bent over piece a little bit. And that way I'll get a little more friction when they actually connect to that terminal. And there we go. That's a much better connection. It's actually feels pretty good. So that will work. And I'll do the same to the other one. And then I routed that coming off to the side. And then I just have it bending down, going down. Everything is zip tied together so it stays nice and neat. I just have to trim all these extra bits off. For the wire that's going to go between the breaker and the fuse holder, I took a new piece of wire and I crimped a ferrule to the end of it. So that's going to go on the bottom of the breaker. And then I'll just tighten that down, have that go to the back. And then I will have another wire that comes off the other terminal of the fuse holder and goes straight up into the voltage selection block. And unfortunately, this is probably going to be the only one that I cannot heat shrink in any sort of way due to the fact that it's got to span the entire length of all of these contacts. So I will kind of like loop it around this terminal at the bottom and then just, have it come down and attach to that terminal. That will have a piece of heat shrink. And the only other thing that I am going to do is I'm going to take the very short cord that it came with, and I'm going to replace it with a bit of a longer cord that I had. And so this will allow me to situate this, a little bit further from an outlet. This is so short that I actually couldn't just plug it in here to have it like in the shot of the camera. I had to get an extension cord or a power strip to be able to plug it in so I could demo it. So, but I mean, other than that, I'm not really like changing anything else from inside. And just to show how easy it is to attach one of these wires once the terminal and the wire have both been tinned, I'm going to just put a little bit of flux on the surface of the terminal, and I'm going to start by actually heating up the terminal first so I can get that solder to melt, because that's going to be the biggest thermal mass right there. And then bring in the wire, allow that to flow. Just kind of hold it in place there for a sec, even though it's starting to get hot. So there we go. That's a much cleaner, much nicer connection than what was originally on there. And then the only thing to do is to bring the piece of heat shrink that I had already placed on there, because otherwise I'd have to remove it. Just bring that into place. That, cover everything up. And then I just need to heat it up and shrink it. We're on the home stretch, people. I got all the neutral wires, all 4 of them, connected together, and I kind of debated for a while about what I wanted to do, but what I ended up doing in the end is I just stripped all 4 wires. There's the one that comes in from the line, there's the one that goes to the transformer, and then there's the 2 that go to the plugs. I stripped them off about an even length each and twisted them together, and then I put a crimp cap on it, and this is pretty secure, so I'm pretty confident that nothing's going to happen with that. The only thing left to do is to put the USB board back in place. And for that, instead of soldering the wires up on top like they had done originally, I actually soldered them in from the component side, because there were some provisions left there for where LEDs would have been originally. So I got this ribbon of that I had of wire, and the colors are appropriate. So I just soldered them in like that, brought them in. I glued it in with some hot glue on the end so that it's not like wiggling around. Hot glue is not my preferred method of securing things together, but in this case, I didn't really have a choice. So, I mean, it'll be fine. And on the wires for each LED, I actually trimmed the leads, because the whole reason they had that like huge little tube behind it is because they had actually left the entire lead of the LED like in place. So they soldered it like all the way at the end. Well, that's really not necessary. So I trimmed them. I just made sure that, I could solder to like I had enough, about like a 1/4 inch of left of lead there, so where I could solder the wire to. So all I really need to do now is to just shrink all the heat shrink. And so now those are secure, and this thing can go back in the case. Now, I don't particularly care for this USB port being on this thing, but since it came with it, I mean, might as well put it back in. On the LEDs, I try to think of something else that I could do for this, but I think I'm just going to have to glue it back in place, just the same way that they had done with the hot glue. But what I like to do is to get things to adhere better, I like to heat up the area where I'm going to be applying hot glue. That way, when I apply the molten glue, it doesn't immediately cool and form like a really bad bond against the material that it's on, in this case, like the casing. So I'm going to give it a little bit of a wipe with some isopropyl alcohol just to clean it up really well. And then once I put before I put the LEDs back in place, I am going to heat up that area a bit, and then put the LEDs and apply the hot glue, and that should be a pretty secure adhesion of the hot glue. So just giving this a little bit of a wipe. And there we go. I think that's warm enough. It's really just so that the hot glue doesn't cool down too fast before it has a chance to stick. So we got those 2 back in position. And there we go. So just hold that there for a second, just so it doesn't try to come off. Okay, I think that's going to be good. And unfortunately, for the 2 wires that come from the transformer to the USB board, there are no holes that I can put them in through to solder them. So they do have to be soldered to the board where the each 2 of the diodes for the bridge rectifier come in.
So I will do that. I'll do it the same way, except that I'll bring them to the back, and then I'll put like a blob of hot glue there to secure them so that they can't like wiggle around and break off or anything. And I'm just going to add a little bit more solder to each one of these points on the board. And a little drop of flux. Kind of doing this at an awkward angle because I'm trying to keep it in camera, but I have to have it tilted up because otherwise this blocks the view. And there's the second one. There we go. And then blob with hot glue, put it on the board, put them down, and put a little more on top. Okay, so that's nice and secure now. And you may be wondering why I didn't just trim these so that the length, kind of matched up a little bit better. That's because when it comes to transformers, I don't like trimming the wires that come out of it, because if anything ever happens, it's very difficult to add wire to a transformer without cutting it up. So I'd rather just leave the wires, as long as they are, and I'll just zip tie them. That way they kind of stay a little bit neater. They're not like flying around all over the place. And there we go. I think it looks so much better now than it did originally. Everything is nice and neat and well soldered. So I think this thing is going to be definitely a lot more reliable than it would have been otherwise. It's not necessarily going to work any better, but at least I can sleep better at night knowing that this thing's not going to like suddenly something's going to break off or it's going to have like some sort of catastrophic failure. So I'm pretty happy with this. Leave any feedback or criticisms or anything that you might have like done differently, go ahead and leave it in the comments. I'd be interested in knowing what others think about this. So there we go. Now let's just give it one more little run just to be sure that everything works correctly. But like I said, I didn't do anything crazy. We just cleaned things up and made them neater. Okay, so let's just double check that everything's still working correctly. And since I don't have the cover on, I'm going to avoid, sticking my hands in there or anything. Not that I need to put my hands in there for any reason, but it is a little bit dangerous inside. So let's go ahead and turn it on. And I mean, that lights up. That means that the USB board is working. We've got the neon on. And let's bring up the multimeter. There we go. Okay, so this one should still be about 120 volts. And sure enough, it's kind of funny how it like bumps up to 120 right away and then it drops down a little bit. And then the 240, that's definitely working correctly. And then we can check the USB. I have this little cord here that I've made just for like testing stuff. So plug that into there, and I need to set this to DC. So we got ground and we got positive. So should be about 5.3 volts. It's a little on the high side, but it's not that big of a deal. So that's working. So everything looks pretty good. All right, there we go. So I've got the case reattached. All the screws are in place, and I have put the handle, the carrying handle back on. And the only reason I had taken that off was because, I had it kind of stored. It's really awkward to like put anything on top of it due to the fact that that's kind of bulgy. So I took it off and I just put it inside until I got around to messing with it. And like I said, I've had this for years, and I've been kind of meaning to do this for a very long time, and finally got around to it. So yeah, there we go. I'm pretty happy with the results. And if you've got one of these things, maybe you might want to take a look inside and see how yours looks. I don't know that they all are going to look the same. But yeah, this one was pretty terrible. So there we go. All right, everybody. I hope you learned something from this. Thank you all for watching, and I will see you guys around the bench.